Okay, so we've both seen the reports on Tropical Cyclone Jude hitting Mozambique, and you also sent over some general background info on cyclones.
That's right.
So I thought for this deep dive, we could maybe use Jude as a kind of a case study, really unpack what's important to know about these massive storms.
Sounds like a good plan. Yeah, tropical cyclones, fundamentally, they're these huge rotating weather systems. They form over warm tropical oceans.
Right.
And they bring, the strong winds, loads of rain, and often that dangerous storm surge.
And they have different names depending on where they are, don't they?
Exactly. So you hear hurricanes in the Atlantic and Northeast Pacific, typhoons over in the Northwest Pacific,
Okay.
and then cyclones like Jude in the South Pacific and the Indian Ocean, which is, of course, relevant for Mozambique.
Got it. So what actually kickstarts these things? What are the ingredients?
Well, you need a few key things to come together. First off, that warm ocean water is
Mm.
crucial. It needs to be at least 26.5 degrees Celsius deep enough down. That's the fuel.
26.5,
Okay.
the fuel.
Yep. Then you need plenty of moisture in the air rising up from that warm water. And importantly, the winds higher up in the atmosphere can't be changing too much, what we call low wind shear,
Low wind shear. Why is that important?
because it lets the storm structure build vertically,
Yeah.
without getting torn apart. And usually you need some kind of existing weather disturbance, like a cluster of thunderstorms, to give it a nudge, help it start
Wow.
spinning.
So it's like a combination lock almost. Everything has to line up.
Pretty much. It's a bit of a feedback loop, really. Warm water evaporates, the moist air rises, cools, condenses, releases heat.
Which warms the air more.
Exactly. Makes it rise faster, pulls in more moist air from below, releases more heat, and the whole thing starts to spin up faster and faster because of the Earth's rotation. It's quite a process.
It sounds incredibly powerful just from the formation. So if we could like slice one open, what's the structure? What did Jude look like inside?
Right. Think of it like concentric rings.
Okay.
At the very center, you've got the eye. Surprisingly calm, often clear skies, light winds.
The calm before the storm, literally.
Or during the storm, in this case.
Yeah.
But right around the eye is the eye wall. That's the most intense part, strongest winds, heaviest rainfall. That's the real powerhouse,
Okay, eye wall, that's the danger zone.
definitely. And then spiraling outwards from the eye wall, you have the rain bands. These are, well, bands of thunderstorms and rain that can extend hundreds of kilometers out. They bring heavy rain and gusty winds too, just generally less intense than the eye wall.
So when Jude hit Mozambique, it was that eye wall doing the most immediate, intense damage, presumably.
Very likely, yes,
Mm.
along with the hazards it brings.
Right, hazards plural. It's not just wind, is it?
Yeah.
What else comes with a cyclone like Jude?
No, absolutely not just the wind. Storm surge is a huge one. That's the rise in sea level pushed to shore by the storm's winds. It causes massive coastal flooding, often the biggest killer.
Wow. Okay.
Then there's the rainfall itself, just immense amounts of rain leading to widespread flooding, especially in river basins.
Okay.
We definitely saw reports of that from Mozambique with Jude.
Yeah, the flooding looked extensive.
And obviously the high winds cause direct damage, buildings, trees, power lines, infrastructure,
Mm.
and sometimes you can even get tornadoes embedded in those outer rain bands.
Tornadoes, too. It's a whole package of destruction.
It really is a multi-hazard event.
Now, inevitably, the climate change question comes up with events like this. Is there a link? What's the connection between climate change and cyclones?
Yeah, that's a major focus of research. And the science suggests several potential links. Warmer oceans clearly linked to climate change, provide more energy, potentially allowing storms to get stronger.
More fuel, like you said.
Exactly. There's also evidence suggesting that climate change might be increasing the amount of rainfall these storms produce, just more moisture available in a warmer atmosphere.
Makes sense.
And some studies suggest storms might be moving slower, which sounds maybe counterintuitive, but it means they dump rain over one area for longer, prolonged impacts.
Right, more time to cause flooding.
Precisely. Yeah. And there's also some concern, though maybe less certainty here, about seeing a higher frequency of the really intense storms category 4 and 5. So we can't point to Jude and say climate change caused this specific storm, but it's definitely changing the background conditions. It's loading the dice, potentially making these events more impactful.
Okay, so summing up. Tropical cyclones, hurricanes, typhoons, cyclones like Jude, they need specific warm water and atmospheric conditions. They have this distinct eye wall rain band structure,
Mm-hmm.
and they bring multiple threats: surge, rain, wind, even tornadoes. And climate change is likely influencing their intensity and rainfall.
That's a good summary, yeah. Understanding those pieces really helps put events like the one in Mozambique into context.
It certainly does. It really makes you think, though. With our climate system being so interconnected, what other extreme weather events, maybe ones that seem unrelated, might actually be influenced by some of the same large-scale factors that juice up these cyclones? Something to ponder.
Definitely food for thought.